Welcome to the BusFinder7264 Pro tutorial video for eDP. First, open the BusFinder software and select Protocol Analyzer mode. Then in the protocol list at the upper left of the screen, choose eDP. For display-related protocols, we also offer MIPI D-PHY solutions, including both CSI and DSI. When it comes to memory protocols, we support a wide range of solutions, including eMMC, SD3.0, SD4.0, UFS, and NAND flash. Now, returning to the eDP settings screen, you can configure the number of lanes and the main link data rate. If aux data isn't detected during capture, the system will automatically use the configured main link speed. Once these basic settings are in place, you're ready to begin capturing data. We'll cover the settings in more detail shortly. Click Run to start the capture, then turn on the display of the device under test. The BusFinder immediately streams the captured data to your computer's hard drive for storage. The built-in 32 gigabit memory acts as a temporary buffer. Once it's full, data capture will stop. eDP data is quite large, so even at full capacity, we can capture only about 140 frames. We've already parsed over 30, so let's pause here and review the results. On the left side of the screen is the main link data, and on the right is the aux data. Let's start by looking at the main link data on the left. The data is organized by type with detailed entries for lanes 0 through 3. For example, selecting a scrambler reset entry brings up a detailed analysis on the right, including the raw data for each lane. You can also search for specific data to view and analyze in detail. For example, entering MSA will display bit level details for each field in the panel on the right. Next, let's take a look at the aux data. The system parses every bit at each address directly from the raw data. We also provide a comprehensive statistics feature that automatically categorizes all data types. Using the report list and opening the statistics view, you can quickly filter and locate the data you want to analyze. For example, you can locate all TPS3 entries, and with a simple double click, jump directly to their positions in the main report. Aux data is also compiled and presented for easy review. We also provide a hide items function, which lets you temporarily hide any data you don't need. Once selected, only the remaining content will be shown on screen. This feature is ideal for quickly narrowing in on specific data within large protocol captures. Click Clear to restore and display all data again. We also provide an image recovery function, allowing you to reconstruct the 39 frames that were just captured. Since the eDP resolution and vStart are defined by the MSA data, no additional configuration is needed on the left. We can see the entire display power-up sequence fully reconstructed. Next, let's go through the configuration details. First, set the lane count and the main link data rate. Then select the appropriate DP or eDP version. After that, choose the options that match your device under test. For example, ignoring aux parameters, disabling descrambling, or skipping link training. In the bottom left are the probe settings. You can remap lanes or swap the P and N signals. Trigger functions are divided into main link and aux channel. For main link, you can set a key code or pattern, such as MSA, SDP, or BS data. For aux, triggers include request start, reply start, and timeout. You can define patterns by byte, command, or address, with the command name shown above for easy setup. After a trigger occurs, it's marked in the report with a triangle in the main view. You can also trigger an oscilloscope through the rear signal port to capture analog waveforms in sync with the data. External triggering is supported as well, allowing the oscilloscope to control BusFinder capture directly. The filter function uses firmware-based filtering to reduce captured data and significantly lower memory usage. One of the most commonly used features is filter pixel data. You can filter out all pixel data or capture one frame every set number of frames, up to 1 out of every 128. This helps prevent the memory from filling up and allows for longer capture sessions. Additional options include folding continuous TPS data, ignoring unknown signals between TPS and sleep, and detecting the TPS end signal. Finally, there's the waveform inspection function used to verify the wiring. If the connection is correct, you'll see an irregular square wave. If not, it appears as a regular square wave. This feature is for wiring checks only. It can measure either the P or N side across all lanes. Do not connect both at the same time. For hardware setup instructions, please refer to the user manual for detailed guidance. The device under test runs at 3.24 gigabits per second, while BusFinder supports capturing eDP signals at rates up to 5.4 gigabits per second, providing ample margin for high-speed analysis. That concludes this demonstration. Thank you for your time. For more information and additional resources, please visit the Acute website.